So let's do the next set of binary games in bytes. Start with the summary of it. So we already talked about this. In base 10, you have a 1 place, a tens place, and a hundreds place, and we're all used to that. So this means 100, that means 40, and that means 7. And let me see, I think it's not fitting on the screen quite right. Let me fix that. Yeah, that's better. All right. There. All right. So in base 2, all you have is 0 and 1. So you've got a 1's place, a 2's place, and a 4's place. So this is 5. And you can count to 7 with 3 bits. The highest thing you can get to is 7, 1 plus 2 plus 4. And with 4 bits, you can get to 15. We did this last time. 1 plus 2 plus 4 plus 8 is 15. So 4 bits, the nibbles only go from 0 to 15, a total of 16 possible values. That's a nibble. So a byte is 8 values. And this, by the way, is the hardest way to do it, but it is the easiest to understand, and it's how most people start out. So you just continue the same pattern. This is 1s, 2s, 4s, and 8s. So this is 16s, 32s, 64s, and 128s. So this number, 1001, 1001, is going to be this, 128 plus 16 plus 8 plus 1, taking these numbers and adding them up. So if you can do that right, and I often have to have like a pencil and a scrap of paper to do this kind of thing, it's 153. Now it's much easier if you use hexadecimal, but that'll be the next class. This is the old-fashioned way to do it. So you should be able to interpret bytes, although you might be a bit slow at it doing it this way. And so let's try a couple of little games here, show you how they work. Okay. And let's see if that's visible on the screen. It looks pretty good. Now I put a space in the middle of the byte just to make it easier to read. That is not standard, but when I have 8 bits in a row, I can't really see where they are, so I break it up into 4 and 4. So here's a byte. What is that byte in decimal? Any guesses? Okay, I've got it. Yeah.
69?
69. It is 69. Now, how did you get there?
Well, I went to the leftmost one and saw that was 64.
Right. This is the leftmost one at 128. This is 64, right? And now you just add 5, right? Yeah. That's why I was able to do it a long time ago. This is 64, and that's 5 more, because that's 4 plus 1. Because it's 1, 2, 4, 8, 16, 32, 64. So you have 64 here. And here you have 1 plus 4, which is 5. So 64 and 5, that's 69. All right, how about this one? Oh. Oh, okay, I got it. Got it wrong the first time, but I got it right the second time. And there's no time limit on these, so if it takes you a while, it's all right, but with practice, you get pretty fast. If you take Cisco training, you get really fast, because you have to do this all the time.
111?
Cisco routers. You learn how to program routers.
No, is it 111?
What are those?
111 is 100.
Good, 111. I like that. How did you get there?
From the 8 bits, we make a byte.
Yeah. So the one, the 0, there's none of that. What's this one?
That one is 64.
Right, 64 and 32. That's 96, and this is 15. So it's 96 plus 15, which is 111.
Oh, you go from left to right. Oh.
You can go either way, whatever works for you. You can also go this way, but I know this is 15. It's the biggest nibble.
Yeah.
So that's 15, and this is 6 times 16, which is 96. Or you can do it by adding 64 plus 32. Yeah, so you got 111. That's good. Let's do one more. How about this one? That should be easy.
64.
It is 64. You're right. I was thinking 128, but you're right. It's 64. Good. All right. So anyway, when you get enough of those right, you'll find a flag and you can turn it in and get some points. And there's another one going the other way here. All right. So what's 2 in binary? This is decimal to binary as opposed to binary to decimal.
10.
Yep, it's this one. 1, 0 is 2. How about 19? I got it.
Would it be 1, 0, 1, 0, 1?
That's not an option.
I don't know.
So it's no. One of these is right. Anybody else got it? Yeah, it's the left one. How did you get there? Yeah, so I mean, I just look at it and immediately say this is 16 plus 3. That's 16, that's 3. If you know your nibbles, it helps. That's why I try to do them one step at a time. You got to understand the nibbles or it'd be very painful to solve these. How about this one, 68? I've got it. The same logic as the last one should make it fast. Yeah, you got it? Okay, thought you were raising some. Yeah.
0, 0, 1, 0, 0, 0, 1.
I don't think that's an option. I don't see any 0, 0, 0, 1 for the last 4. And something's wrong. Besides, it can't end in 1 because it's even, 68. Even numbers are also even in binary. Yeah, go ahead.
Is the second one from the left?
This one here, I think it is, because this is 64, and then you add, nope, that's not this one. This one is 66. Second one, okay, this one, right. It's this one, 64 plus 4. That's 64, and that's 4. Okay? We'll do one more of these. 63. This is one that you really can do easily if you know your Cisco subnet. Yeah.
Is it 1, 0, 0, 0, 0, 1, 1?
No. That's odd, though. Of course, they're all odd, so you don't have a mistake. No, but this is 65. 64 plus 1. Yeah.
Would it be 1, 1, 1, 1, 1, 1?
Yes. It's 64 minus 1. The 64 is over here. When you subtract 1, all the rest turn to 1s. That's the easy way to do it. Of course, you could also add 32 and 16 to get 48, and then 15 to get 63, but that's the hard way. The easiest way is to know when you subtract 1, this turns to 0, and you go 0, 0, 0, 1, 1, 1, 1, all the way around. Anyway, all right. So, like I say, that's good stuff to do. It's here for extra credit, but I highly encourage you to do this and get some practice with binary because you will keep hitting it. It's like if you're a musician and you don't know how to read music, you will keep on being humiliated until you're forced to admit you have to learn to read music. If you don't know, you need computers and you don't know binary, you will be compelled to sooner or later. Anyway.